In this video, we're going to consider a figure of a DFA M and determine which statements are true. Okay, so it's a little fuzzy, but this is our DFA M. Okay, the first statement says that M001 is an element of ADFA. Okay, so ADFA is a language. The language is the set of strings BW, where B is a DFA, and B accepts the string W presented. Okay, so how would we decide if M001 is an element of ADFA? We would trace M on 001 and see whether or not it accepts. Okay, so if we have our string 001, so we're in the start state, which I am assuming, is here. Okay, let's make that a little bit more clear. The picture is just a little bit fuzzy. Okay, so we're in the start state. Let's label it. Let's call it Q0, and let's call this Q1. Let's call this Q2, just to make it easier to talk about it. Okay, so on a 0, what do? I stay in Q0. So I've read that one. All right, I'm still in Q0. I'm reading a 0. I stay in Q0. Okay, now I'm in Q0. I'm reading a 1, and I go to Q1, and that's where I end. Okay, so M does not accept 001, so it cannot be an element of the language ADFA. So that one's false. Okay, second statement is that description of M is an element of EQDFA. What is EQDFA? It's the set of strings A, B, where A and B are DFAs, and the language of A is equal to the language of B. Here, notice what the format is of strings in EQDFA. It requires 2 DFAs. The string we're presented with as a candidate for that language is only 1 DFA. Okay, so this string cannot be in the language. If we had modified the string, so this is not in the language. If we had modified the input to be this, is this in the language? Okay, well, does it satisfy the condition? M would be A. M maps to input A. So then M is a DFA. This other M maps to input B. So M is also DFA, right? And the language of M is equal to the language of M. That's pretty obvious. So it would work here, but it does not work as originally stated. Okay, so that one's false. Last statement. Description of M is an element of the language SOMEDFA. And what's the language SOMEDFA? It's a set of strings that are a description of a DFA, and its language is not empty. Okay, so to decide if M is an element of SOMEDFA, we just need to find out if M is a DFA. It is. We already said that. And the language of M is not empty. Well, if we look at our machine, we see that if we come in at the start state, Q0, we immediately accept. So we accept epsilon. What else do we accept? Well, right there, that's enough, okay? So if it accepts epsilon, it's not empty. So this is true. We could go on if we wanted to and say, okay, it also accepts 0. What else does it accept? It could accept 1, 0, 0, and then repeating zeros, whatever we want, okay? But the fact that the start state is an accept state, that is enough to prove that this is true, that its language is not empty. Okay, so something here to be very careful with is that let's let some language L. If L contains the empty string, then L is not the empty language. Empty string and empty language are not the same thing. L is the empty language. Let's call it something else. Let's call it J. Language J is the empty language if it has nothing in it. Okay? This is equal to the empty language.